Hey everyone, it's Miss Bellman. We're in Unit 5, Lesson 13. This is all about writing equations. Writing exists in math too. I know, sounds crazy, but it does. It truly does. It's not just for ELA. We write all the time, and this time we're going to be decoding and looking at two different companies that we want to see unit rate or, price per cost. This is going to be a lot of fun. At least I am. I'm excited. So Seward Elementary School is considering buying bracelets from a fourth company. So Company D charges $3 for 20 bracelets, and there's $2 in shipping. So it's just for those, there's $2. So we want to find the cost of one bracelet, not including the shipping. So I just imagine this in my mind where there's 20 bracelets. So I'll just draw them out. So there's 20 circles. And if I'm looking for the cost of one, am I adding? Am I multiplying? Am I dividing? Am I subtracting? Well, I'm going to be dividing to find the cost of one. I know that 20 is $3, but I just want the cost of one. Again, just one, so I will be dividing. I'll be dividing $3 by 20. So when I do that, I'm going to get the price per bracelet. And it would say this bracelet and this much to make the total. Or I could say 20 multiplied by something equals $3. I could do that too. Remember, multiplication is repeated addition. So when I set this up, I have my little house and there's going to be $3 or 3.00 inside it, and I multiply it by 20. That's how many bracelets I have total, and I want the cost of just one. It ends up being 15 cents. I know this because I try to put 20 into just 3 and that doesn't work out. So 20 into 30 because I have the ones and the tenths, and I get 1 and then 15. So it's 15 cents per bracelet. So if I took 15 times 20, that would give, 0.15, 15 cents times 20, that would give me $3. Yay, that's great. So I know that right now. So now I can take the information that I got from doing that, and now we're looking for N bracelets. Remember, that's a variable. It could be anything. It could be 3, it could be 4, it could be 5,000, it could be 5 million. But I will be multiplying it by 0.15 because we figured the cost per bracelet. So when I have the N, maybe it's 55 bracelets, and I multiply that by 0.15, I would get the total cost, but no shipping. So I, in my mind, set this up two ways. N multiplied by 0.15, or I could say 0.15 N. So no matter what number I put in for N, because it is a variable, I will still multiply it by 15 cents. When I have an equation like this, I am so ready to set up for any kind of number of bracelets that I'm given. So they could say, Miss Bellman, how many bracelets, or how much would 40 bracelets cost? And I could say, huzzah, I already have that. So it's going to be N times the cost per bracelet plus $2 for shipping, which we're going to look at in number 3. So N is the number of bracelets the school buys. We don't know how many they're going to buy, but it's that N. And T is the total cost. So that's how much it's going to cost. So the total cost in dollars of the bracelets. Now this one is going to include the shipping because we're including the shipping, and it's just a flat $2, no matter how many, 5, 10, 5 gajillion. It's $2 in shipping, so that's a pretty good deal. We're going to be adding it. So when we write this, it'll say T is equal to, because that's the total, is equal to 0.15 N, the number of bracelets, plus 2. $2 is the shipping. And I'm adding that. I'm not subtracting, I'm not multiplying, I'm adding that. So no matter what number I put in for N, I'm going to multiply that by 0.15, which is the cost per bracelet, and then add $2. So number 4, it says explain what each term on the right side of the equation tells about the situation. So again, terms, we can only add, subtract. We know that when I multiply 0.15 times N, that's going to give me the cost of total bracelets. So 0.15 is the cost of one. The N is the cost for N number. And it could be any number. The 2 is very specific to the shipping. Now, in this problem, they didn't tell us that, for every 100, it's so much. For every 200, it's so much in shipping. It's just a flat $2. So we don't have to worry about anything other than that. But again, keep in mind that this equation that we have set up here, any number you put in for N will work as long as you multiply it by that 0.15. If you remember back to the first picture I drew with 20 circles being those 20 bracelets, it was like saying 0.15, 0.15, 0.15. All of those added together, or 20 times 0.15, is where I got that $3 from. So I found that unit rate, and it helped me write the equation. So the cost equation for company A, so this is a different company, is the total is equal to 0.125 N plus 4. So their shipping is a little bit more expensive. So we're going to compare company A to company D for a better price on 50 bracelets. So they're only buying 50 bracelets. Maybe it's just for like SOAR tickets. We could have them at our school too. So I only want 50. I'm going to plug that 50 into my first equation, which is 0.15 plus or multiplied by N, in our case 50, plus 2. So 50 bracelets at 15 cents each plus the $2 for shipping. When I multiply this out and I add everything together, I get a total of $9.50. Now, that seems like a pretty okay deal. I mean, I'm not in the bracelet business, but in my mind, that seems like a pretty legit deal. That's for company D. Now, let's look at company A. Company A is 0.125 multiplied by 50 plus 4. So their shipping is more expensive, but we will soon find out if it'll be more expensive or less expensive. Which one do you think is going to be a better deal? Ooh, it's going to happen. Now, if only I would have known to move my paper up, this would be a heck of a lot easier. But once I multiply 0.125 by 50, I end up getting $6.25, but I have to add $4 and I get $10.25, right? So company A, even though I'm ordering the same amount, it's actually more expensive. And I do think it's due to that, the shipping cost. If the shipping cost was the same for company A and company D, company A would have been a better choice, but it was more expensive. So let's look at the next problem where the school knows they're going to make it rain SOAR tickets. So they're going to order 200 bracelets. So with 200 bracelets, this drastically changes the number for the total cost. So I do 0.15 multiplied by 200. That's like having 200 bracelets at 15 cents each. So I'd say 15 cents plus 15 cents plus 15 cents plus 15 cents. I mean, I would do that 200 times, or I could multiply it because multiplication is repeated addition. I can multiply it and make my life a heck of a lot easier. So total, once I do this, I get $30. I add $2 for shipping and I get $32. Still kind of a good deal. I mean, I think that's pretty good deal. Again, not an avid bracelet buyer, but I guess I'd buy them. But we need to look at company A. Company A charges 0.125 cents per bracelet. So I could say 0.125 plus 0.125 plus 0.125 200 times, or I could multiply because it's repeated addition and I get a total of $25, and I would add $4 for shipping and I get a total of $29. So in a really strange way, I actually save more money buying more bracelets with company A than I do with company D. Even though company A charges more for shipping, it still charges less per bracelet. Kind of crazy, right? That's how math works sometimes in the real world. Thanks for joining me.